Welcome to The Explainer. Today we're diving into the unsung hero of network stability. It's a protocol that works behind the scenes, quietly keeping millions of devices from falling into chaos so our digital world can just work. We're talking about SNMP.
Think about it. Picture a huge company's network. You've got thousands of routers, switches, servers, all chattering away. How on earth do you keep tabs on all of them? Going to each one and asking, "Hey, you doing okay?" would be absolutely impossible. You'd be pulling your hair out.
And that right there is the exact problem SNMP was born to solve. See, a network without management isn't really a network at all. It's just a bunch of noisy, uncoordinated gadgets. To get beautiful music, to get harmony, you need a conductor.
So, let's meet our conductor, the Simple Network Management Protocol, or SNMP. And don't let that name fool you. Its role is anything but simple. It's profoundly important.
At its core, SNMP is basically a universal language. It's an application layer protocol, which means it allows all these different devices, made by all different companies, to report on their health and status to one central spot.
Okay, so let's break down how this whole orchestra thing actually works. To make it all happen, SNMP really relies on three key players working together in perfect harmony.
First up, you have the SNMP Manager. This is your conductor standing right on the podium. It's a centralized piece of software, usually running in a network operations center or a NOC, giving an admin that single pane of glass to see everything that's happening.
Next, you've got the SNMP Agents. And these, of course, are your musicians. An agent is just a little bit of software that runs on every single device you want to monitor. Your routers, your firewalls, the whole shebang. They just sit there waiting to be asked how they're doing.
And finally, the big question. How do they all speak the same language? Well, that's the Management Information Base, or MIB. You can just think of it as the sheet music for the entire orchestra. It's a shared rulebook that makes sure when the manager asks about CPU usage, the agent knows exactly what that means.
So the key thing to remember is this. The manager is the active part of this duo. It's the conductor, constantly asking for updates. The agent is more passive. It's the musician, just waiting for a question, or, and this is super important, sending up a flare if something suddenly goes wrong.
Okay, so how does this conversation actually happen? What does the conductor really say to the musicians during the performance?
Well, they use a whole set of specific messages to talk to each other. Now, you can see there are quite a few here, but let's really focus on the three most fundamental interactions that make up the heart of SNMP.
The most common one you'll see is a GET request. This is the bread and butter. The manager or conductor simply sends a GET request to an agent asking for one specific piece of info. The agent grabs that data, like say its CPU is at 15%, and sends it back in a GET response. It's just this constant, steady check-in.
But wait a second. What happens if something goes wrong unexpectedly? A device can't just sit around and wait for the manager to ask if it's on fire.
And that's where the trap message comes in. A trap is a proactive alarm. It's an unsolicited alert. If an interface on a switch suddenly dies, the agent doesn't wait. It immediately fires off a trap message to the manager, basically shouting, "Hey, pay attention, something important just broke over here."
Now, this is where the story gets really interesting. When you have a system that can literally control your entire network, you better believe security is everything, and SNMP has had to seriously evolve.
So, the protocol has gone through three major versions, and each one was really a step up in security. The original, SNMP v1, was totally groundbreaking, but it used these simple passwords called community strings. Version 2C added some new features, but kept that same kind of flawed security model. It wasn't until SNMP v3 that we got the robust, modern security we really needed.
And this right here shows the night and day difference. With versions 1 and 2C, those passwords, the community strings, were sent in plain text, wide open for anyone to see. SNMP v3 completely changed the game. It brought in real user authentication and, crucially, encryption to scramble the data. That's so important for stopping not just eavesdroppers, but bad actors who might want to hijack the system.
SNMP v3 is also really flexible. It offers three different security levels. You've got no auth, no priv, which is, well, no security. Then there's auth, no priv, which is better. It authenticates the user. But the gold standard, the one everyone should use, is auth priv. That gives you both authentication to prove who you are, and privacy, which encrypts the entire message so no one can read it.
So, why does all this matter? After all these decades, why is this protocol still a cornerstone of every modern network?
Well, for one, it's incredibly lightweight. It uses UDP, which is a really fast, no-frills way to send messages. Managers are typically listening for requests on port 161, and they keep port 162 open to catch all those urgent trap alerts we talked about.
But here's the real magic, the reason SNMP is so essential. It's what lets you proactively monitor your network's health. It gives you those real-time alerts that let you fix a problem before your users even know it happened. It lets you plan for the future by tracking bandwidth. It is, in short, what keeps the entire business online and running smoothly.
And that's why, for any serious, large-scale operation, SNMP isn't just a nice feature to have. It is an absolute requirement. You could even say it's the nervous system of the modern network.
Because when you think about it, without proper management, a network is just a bunch of expensive boxes making noise. But with it, you can get a beautiful symphony. So the question to leave you with is, who or what is conducting your network's orchestra?